Okay, lesson 5.5, building 3D shapes with nets. Our last lesson of our flipped classroom for this week. I hope you guys enjoyed this experience. We're going to get some feedback from you next week about what you thought and see if this would be something that you think would be beneficial as being part of our regular math class. So for today's objective, it says today I am identifying and assembling geometric nets and comparing geometric solids. Why are we doing that? So that you can visually match solids to nets. And today I'll know I've got it when I can successfully connect each net to the solid it represents. So I'm sure you're a little confused what we're talking about when we say net. We will clarify and you will love them. Fun lesson coming up, lots of construction for you to take care of at home. Before you left today, you should have gotten, and left I mean school, you should have gotten this Math Master Sheet, page 218. You'll notice it has 4 figures that you're going to cut out eventually and form into cubes. We're not going to do that just yet. So I'm going to go to that page so you have it in front of you. If you need to pause here to go find that sheet, that might be a good time to do so. I'm going to get rid of myself here. Okay, so in front of you for today's math message, you'll notice it says use the patterns on this page, make a conjecture. Okay, conjecture is a guess. You make an educated guess, make a gut feeling about what you see in front of you. Which patterns can be folded into cubes? Okay, so down below we have A, B, C, and D, and without cutting them out, without doing anything else, just by looking at them on paper in that flat, and this is actually a net, we're going to talk about this in a minute. A net is a 3-dimensional shape decomposed or broken down into a flat 2-dimensional shape. So just by looking at this page, and you can just list them up here next to number 1, which of these do you think could we form into a cube? Okay, good time to pause for thinking, and I'll be here when you're back. Okay, if you're back with me, you should have selected A, B, and C as the 3 cubes that you could form into cubes, or the 3 figures that you could have cut out, folded on the dotted lines, and formed into cubes. So what I would like you to do now is, again, you're going to pause, you're going to take some time to cut these 4 figures out and fold them into cubes, and I'm going to come back onto the screen to show you what they look like. You're going to need small pieces of tape, and you're going to connect them together to form cubes that are about this big. Okay, now when you're looking at D, I want you to notice why it doesn't form a cube. What about D makes it unsuccessful to be folded into that cube shape? Okay, good time to pause, have some scissors handy, cut them out, and I'll be back here when you're ready. Okay, so if you're back, we're going to talk about some vocabulary. Again, we briefly mentioned that the drawings or figures that you saw in front of you on that Math Masters page 218 were called nets. And the definition of a net is in front of you. It says a net is a 2-dimensional figure that can be folded to form a closed 3-dimensional shape. Pardon me. Which is what you did. Okay, you took that there were 6 cubes, you folded them together, you taped the edges, and you were able to form a cube with A, B, and C. What you formed were geometric solids, and this is the surface or collection of surfaces that surround a 3-dimensional shape. Excuse me, I'm sorry. The edge of that cube is a line segment or a curve where 2 faces meet. So I'm going to come back on the screen and I'm going to show you what I mean when we're talking about a cube, or an edge, excuse me. So here's your cube. Now an edge is where you actually taped the 2 sides together, or they might have just been a fold, and this is an example of a fold here. Okay, this is an edge of our cube. Okay, it's where those 2 faces met and here we use tape to connect them. But this is an edge of your cube. And just to clarify, a face is any flat side. And we talked about faces a few lessons ago when you had to look around your house and find faces to sketch, those polygons. So a face is any flat surface. So you'll notice on a cube, we have 6 faces, as well as 1, 2, 3, 4, many edges. Okay, count those in your free time. Okay, so we have congruent. So a congruent is when, or we describe things as congruent, is whenever we have the same shape and the same size. Okay, so you'll notice that the faces of your cube are all congruent, which brings them all together to form that cube for us. Okay, so all of the angles were the same, all of the side lengths were the same, and it easily brought them together to bring that cube for us. So this is basically all you need for today's lesson. I know, brief. You're used to seeing me for 10 to 15 minutes, but I'm going to stop pretty early for you today. So again, a net is when we take a three-dimensional shape, we can deconstruct it, we cut it at its edges, and we lay it flat. You'll notice that the edges are still connected in certain areas. And when I bring that net together to form that three-dimensional shape, I have less edges than I did when it was in the net form rather than the three-dimensional shape form. Okay, geometric solids, that's what we have when we actually take that net and then form it into its three-dimensional shape. Okay, the edge is where our faces meet. And you'll notice that you have less edges when you actually form that geometric solid. So our net's going to have more edges than our geometric solids do because I'm going to have those faces joining and bringing down the number of edges. And also congruent is when I have side lengths, maybe angle lengths that are the same shape and the same size. So that's all you need for 5-5. Again, this is the end of our flipped classroom. I hope you enjoyed this experience, and I will see you on Tuesday. Enjoy your day off on Monday.